Welcome back to the Lambda Container Images Learning Path. In this session, you'll learn an introduction to the Open Container Initiative format, or the OCI image format. As a first goal, you'll learn what the OCI format is. You'll learn what you need to put into your container image so that it can effectively run on the AWS Lambda service. You'll learn how to build an image using Docker and the AWS Lambda provided base images. You'll learn how to build an image using Docker and third-party base images that you select, for example, to meet compliance requirements or use an existing pipeline. And you'll learn how to deploy those images to the Amazon Elastic Container Registry, or ECR. So let's get started. First, the OCI image format specification. What is it? It's a way of packaging file systems and containers into a single file archive that's universalized to run on different platforms. Now, it's important to know that the OCI image specification doesn't mention anything about how those images are used at runtime. It's simply a definition of the packaging format. And the goal of that format is interoperability. There are a few key elements included in an OCI image. First, there's the image manifest, a JSON document that describes the components that make up the container image. There's an optional image index, and the file system layers, the most important part. These layers are layered on in order by dependency and overwrite one another to eventually build an entire file system. And finally, there's some configuration options that are set in the image. Certain options are ignored by the AWS Lambda service. For example, you can't mount volumes or expose network ports. To learn more information about the OCI image format, see the URL on the slide, s12d.com/OCI-image-spec. So what actually goes into a container image for an AWS Lambda function packaged as a container images? Well, it's important to know that you have 10 gigabytes of space to fit whatever you need. Now, inside there, you must have a Linux operating system running version 4.14 or greater of the kernel. This is a Firecracker requirement. To learn more about Firecracker, please see the previous session. You must have the AWS Lambda Runtime Interface Client, or RIC, installed in your image. For more information on the RIC, see s12d.com/RIC. Of course, you must have your function code and the required dependencies, whether those are per language dependencies or utilities or other data that you expect to be on the file system when your Lambda function is invoked. Optionally, you can add the AWS Lambda Runtime Interface Emulator, or RIE, and this allows you to run or invoke your Lambda function outside of the AWS Lambda service. For more information on the RIE, see s12d.com/RIE. And finally, you may choose to add some extensions. AWS Lambda extensions are a preview feature that allow you to run code alongside your Lambda function, register and listen for events, and send those events to destinations of your choice. It's important to note that extensions must be executable and they must be placed into the directory /opt/extensions to run. For more information on Lambda extensions, see s12d.com/extensions. You can choose to build your Lambda functions packaged as container images from two base images, either the base images provided by AWS Lambda or other generic third-party images. The Docker file you see on the right is an example of a multi-stage build that builds your function using an AWS Lambda base image. On line 1, you see your language-specific builder image, and on line 6, you see the AWS Lambda provided base image that becomes your function. There are certain advantages to using the AWS Lambda provided base images. First, all 6 provided runtimes and the 2 runtime APIs, provided and provided.al2, are available. Multi-stage builds allow you to insert the tool chains that you need for your runtime, but not include those libraries in your finished function, as you see in the Docker file on the right. Just like the runtimes that you use when you use a zip file archive function, these runtime base images are based on Amazon Linux or Amazon Linux 2. The same runtimes are based on the same underlying operating systems. The AWS provided base images include both the RIC and the RIE out of the box, so you don't need to install them. You simply need to add your function code. And for more information on the base images provided by AWS Lambda, see s12d.com/baseimages. Now, there are certain times when the AWS provided base images may not be the best use for your scenario. For example, you may have compliance requirements that require you to inspect or own the entire operating system on your container images. Or you may have made investments in custom tooling or security tooling for the same purposes. In that case, you can build your Lambda functions on top of third-party base images. This Docker file that you see on the right builds a Lambda function on the Python 3.8 runtime on top of CentOS version 7. The limitations are similar to the AWS provided base images. You must use a version of Linux with a kernel version 4.14 or greater. Again, this is a firecracker requirement. You must add in the RIC yourself. And you see this on line 23 of the Docker file on the right when a run install statement is used to install the runtime interface client for Python 3.8. If you want to run your function outside of the AWS Lambda service, for example, to test and debug locally, you will need to add the RIE. In this Docker file, the RIE is added in line 13 when it's copied down from GitHub. And finally, you need a place to store your Lambda functions packaged as container images. And that's the Amazon Elastic Container Registry, or ECR. ECR is a fully managed container registry with both public and private repositories governed by IAM policies. Use of ECR is a requirement for deploying Lambda functions. You cannot deploy Lambda functions from other registries at this time. You can create an ECR repository using CloudFormation, the AWS CLI or SDK, or the AWS Management Console. On this slide, you see the example for CloudFormation on the top right and the SDK or CLI on the bottom. And finally, you can choose to scan container images when they're pushed to your repository as part of the configuration settings. For more information on ECR, please see s12d.com/ECR. So a quick review of this session. What did you learn? You learned about the Open Container Initiative image format, or OCI image format, and what it includes. You learned the components that you must have in your container image to package your Lambda function as a container image. You learned how to build a Lambda function image using Docker and the AWS Lambda provided base images. You learned how to build an image using Docker and third-party base images. And you learned how to deploy that image to the Amazon Elastic Container Registry. For additional details on all these topics, please see the links shown here on this slide. In the next session, you'll learn how to deploy your functions to the AWS Lambda service via the AWS Management Console. Thank you for joining us for this session. I hope you found it useful. As always, all this information and more is available on serverlessland.com.